Um, so graphing secant, cosecant, those graphs are just like graphing sine and cosine. So I tell students they're exactly the same. When you graph, let me get some little examples. So if I'm graphing and I've got my three lines and I'm graphing a sine, we've got cosecant, which pairs with sine. They are reciprocal functions. I was trying to think of the word. And then secant that pairs with, nope, cosine. And one way I tell them to remember who pairs up with who is that each pair only has one co. So for example, I guess I have my volume on. Hopefully. Okay. Sine and cosecant. So there's one co in that pair. And then over here with cosine and secant, there's cosine. So there's a co, a co, a co in each pair. So a lot of times they want to match them up the wrong way, and that doesn't help. So that's how I remember who matches with who. But anyways, if you can graph sine and you've got that basic function that positive sine does that. And these are just a guide. It's like an asymptote. So I tell them to sketch that on and it's not part of your graph. And then from there, you can see where those asymptotes happen, because the asymptotes happen everywhere that your graph crosses that middle line. So we put asymptotes wherever your graph crosses that middle line. And then we attach our curves at the minimum and maximum. And they're similar to parabolas, but they're not the same. They're more like a U. A parabola keeps going out further and further, but a U kind of goes straight up. So. There's the graph of cosecant. And then again, you could take off like all of that. That's technically the graph. We just draw the other stuff as a guide. And then for my cosine graph, if I drew the three lines to help me as a guide, and then I drew that cosecant graph, or sorry, the cosine graph, which is not part of the secant graph. It is just used for a guide. That one's wide, but that's okay. And then I sketch on my asymptotes, which again happen everywhere that your graph crosses the middle line. And then you attach the curves at the minimum and maximum points. They're not pretty. I tell them they don't have to be perfect. I just want to see that they get really close to the asymptotes. And then some resources will just do half of the graph. I don't really care if they put a whole curve. It doesn't matter. But there's my graphs of sine and secant and cosecant. To graph your examples, let's see. You got y is equal to 4 tangent. So to be honest, I don't really pay a whole lot of attention to when the graph is being stretched because it's hard to show that. But for a tangent graph, we still have, it's more the midline, but you could like show them the three lines. And for this one, it's like plus 0, so your midline is at 0, and then we add 4, subtract 4. For tangent, you start at 0, and your basic shape of your graph is like that, but 0 is right in the middle, so that's a positive tangent graph, and 0 is the starting point. 0 is the start. C is the starting point with tangent. And so if, and for tangent, there's only 3 critical points instead of 5. And so for these, for this one, I was going to list everything out. I have my amplitude is 4, my period constant is 1, my phase shift is 0, so I'm going to stay at 0 degrees or radians if you want to do it in radians. And then I'm not shifting up or down, so the midline is at 0. B, for B, when you do sine and cosine, it's to figure out your period. It's always 2 pi divided by B, but for a tangent, the period is 180, it's half. So you do 180 or pi divided by 1, so it's 180 or pi. So I'm going to go put my 3 lines, or sorry, my 3 dots for tangent. And C is the start. So C tells me I'm going to start at 0 degrees right in the middle. And then I have to, for this one, the increments that I do, I'm going to take my period 180, and instead of dividing by 4, I only have 3 points. So I divide by 2 because I have 2 spaces that I need to fill. So 180 divided by 2 means that I'm going to move in increments of 90 before the start and after the start. So I will have 90 and then negative 90, or pi over 2 and negative pi over 2 if you were listing it in radians. My center point is where I'm going to attach my curve, and then the 2 outside dots for my 3 line, or for my 3 dots, are the asymptotes. So tangent has some asymptotes, and then I make my curve. It's hard to make with this pen sometimes, but I've got my curve. If I wanted to be I should have gone through 0, but you know what I mean. The other one that you had. Okay, so that one, negative tangent. Okay, for this one, it's very similar. I'll jot down my parts. So A is 1, but I also need to make note that this is negative. So when I put my curve, not like that. When I put my curve, it will face down instead of facing up. Amplitude is always absolute value, so it's always positive. For this one, B is 1, so again, my period is 180, and I'm going to move in increments of 90, just like the other problem. This one, the only thing that changes is the phase shift. This one, instead of starting at my C starting at 0, I'm going to start at pi over 6, and since it's negative, I start positive. So it's at positive 30 or pi over 6. And then D is also 0. So if I make my 3 lines, and my 3 dots. Oh, I should have added, and I didn't. I should have added my X and Y axis over here. So I'll go ahead and put those on. X would go there. Y would go there. It's more correct to have those on there. I should have put them. So over at that second graph, if I'm labeling, I'm at 0, 1, and -1. And then C is my start. C is at 30 degrees. And then I'm going to add 90. So I get 120. And subtract 90, -60. Put my asymptotes on the outside. And then I can attach my curve, and I'm going to make sure that my curve attaches the other direction because it's negative. And then I'll put my X and my Y. So X goes through 0. Let's see, 0 is a little closer to 30 than -60. So I'm going to put it like right there-ish. So there's my X and my Y. Good luck teaching this. It looks like you did great on your other ones. And I really do like that worksheet. It looks like a good worksheet. I'm always happy to help. Good luck.